Hello, this is Mrs. Davis. This is APP Calculus, Lesson 1.12, Transformations of Functions, and this is Video 3. Right now, we're starting to look at vertical dilations in your notes. Vertical dilations are a little easier than horizontal dilations, but if you think about a vertical dilation, it's going to stretch or compress the y, all right? So we'll work through some of the examples. So first we have a stretch. It's on the outside of the function. That's how we know it is a vertical stretch. So this is a vertical. Now, I'm saying stretch because this 2 is greater than 1. So that would be a vertical stretch by a factor of 2. So sometimes it helps you to do a little table, but if you had, let's write some points down here. I have -4, 3. Okay, this is original. I have -2, 0. I have 0, 2, and I have 2, 0. Now, what I want to do is multiply the y terms, just the y terms, by 2. So I would have the same x and then 2y. So I'm going to just change those numbers. It'd be -4, -2, 0, and 2. But then this would become 6, 0. I'm multiplying that by 2, so that's 4 and 0. So now I can just plot those points. -4 would be up here at 6. And then 0. And then at 0 it would be at 4. And then at 2 it would be 0 again. So we come down straight as I can, and then curved part would look like that. So there is a vertical stretch by a factor of 2. And you can tell it's like if you were pulling it this way and this way, that's vertically, it would get skinnier, okay? So that's why it looks thinner, I guess you could say. All right, let's look at this graph. This time we are doing a vertical dilation. However, it's less than 1. It's between 0 and 1. So we call that a compression, and it should look wider when we're done. So we'll call this a vertical. So it's vertically compressed by a factor of 1/2. So this time, I still would have my same x's, so I'm going to look over here. The graph is exactly the same. And I am going to do it times 1/2 y. All right, so I have a -4, -2, 0, and 2. And then half y would be 3/2, 0, 1. And then, half of, looking over here, 0 would be 0 again. So at -4, it's at 1.5. And then at -2, it's at 0. Okay. And then at 0, it's 1, and then it goes back down to 0. So this is a little wider graph. Okay, so if you're pulling something this way, it looks sort of like a horizontal. Let's say you're pushing it this way. That's a better example, because I don't want to get messed up with horizontal. If you're pushing it in, okay, it will widen the graph. All right, now that's all fine and good. Let's move over to horizontal dilations. Okay, the first thing we need to remember is that if it's 2 times x here, we multiply by a factor of half, okay? And so we have to remember that. So this would be, it's inside the function, so that's how we know this is a horizontal. All right, now, if it's greater than 1 and it's horizontal, it's going to be a compression. And I'll show you why when we do it. So by a factor. Now, there's some wiggle room here, because are you saying this is the factor, or are you saying the factor is when I multiply out in my little XY chart? So I'm going to say of 1/2 to remind myself that I am multiplying by 1/2. It's just when you say the factor of is the confusing part a little bit, and I'll show you something that does that in a minute. And so I'll show you how you can avoid the confusion. All right, so if I start out with my exact same points, a horizontal is going to affect x. It changes x. So my original points were -4, 3, -2, 0, 0, 2, and 2, 0. Now, I would now multiply each x by 1/2. So 1/2 x, and my y's stay the same, okay? So this would be -2, this would be -1, 0, and -1. Okay? All right, and so we would put the same y's, 3, 0, 2, 0. Okay, so at -2, I'm at 3. At -1, I'm at 0. At 0, I'm at 2. And at -1, sorry, this was supposed to be 1, not -1. I'm back down at 0. So we have this graph. All right, now we have a multiplier of 1/2 inside the function, and so that would be horizontally stretched by 2. Okay, I said I'd talk about why this is called a compression. So if we're going this way and I am getting skinnier, the only way to get skinnier is if I was pushing it in, if I was compressing it in. And so that's why it switches to compression. And this one is going to be horizontally stretched, so it should become wider. All right, let's go back to our little chart. We are now going to multiply x by 2. So if I had, starting out here, these numbers, then it would be -8, -4, 0, 4. And then my same y values, 3, 0, 2, 0. So -8, 3, -4, 0, 0, 2, and 4, 0. So you can tell this is really stretched out. And this goes like that. Okay, so there's the new graph. This next example is a reflection over the y-axis. This is a reflection over the y-axis. And so that affects x. So look, if it reflects over the y and I have 2, 1, and then over here I would have negative 2, 1. See how it affects the x? So I'm going to have, the graph is not the same this time, is it? So we're going to just reflect over y, and I can do that without points. So if I'm at negative 3 here, let's see if I can get my pen. I'm at negative 3 here, then I have to be at 3 here. So that would be there. And then if I'm at negative 1, it should be at 1. And if I'm at, negative 1, I'm here at negative 1, this should be at 1. And then if I'm at 1, it should be negative 1. And then if I'm at 3, it should be negative 3. And up here, it would be this. So you're looking at this reflecting over the y-axis. And I'll do one more and then do another video because this one's hard, but this one's not so bad. Okay, so we have several things going on. We have a vertical stretch by a factor of 3 for this one, and then it's translated up 2. So I'm just going to, let's see. Both of those affect y, right? This affects y and that affects y. So really what's happening is my y becomes 3 times y plus 2. And I have my original x. Now, let's start, what did we originally have? Let's get our points. We had negative 3, 0. We had negative 1, negative 2. We had 1, 0. We had 2, 1. And we had 3, 0. So my x's will stay the same. Negative 3, negative 1, 1, 2, and 3. And my y's now are going to be put into this little function. So that would be 3 times 0 plus 2, so I get 2. So at negative 3, I'm at 2. Let me get my pen. At negative 3, I'm at 2. Okay. At negative 1, I have negative 2 times 3, which is negative 6 plus 2, which is negative 4. So at negative 1, I'm down here at negative 4. At 1, I had 0, and that would be 2 again. So when I'm at 1, I'm at 2 again. Okay. At 2, I was at 1, so 3 times 1 is 3 plus 2 is 5. So at 2, I'm at 5. 5 is right here. And at 3, I was at 0, so I'm back to 2. So at 3, I'm at 2. So we have a very stretched graph. All right, I'm going to stop this video there because this next one is quite a challenge. I'll probably just have one video on that one.